Good morning to one and all. My name is Sheikh Muhammad Iqbal. I am from 3CSCD. Today I am going to give a seminar in computer organization about the topic Go Back and RQ. So let us dive into my seminar. Before understanding the working of Go Back and RQ, we first look at the sliding window protocol. As we know that sliding window protocol is different from stop wait protocol. In stop wait protocol, the sender can send only one frame at a time and cannot send the next frame without receiving the acknowledge of the previous sent frame. Whereas in the case of sliding window protocol, the multiple frames can be sent at a time. The variation of sliding window protocol are go back NRQ and selective repeat ARQ. Let's understand what is go back NRQ. What is go back NRQ? N is the go back NRQ. N is the sender window size. Suppose we say that go back 3, which means that the 3 frames can be sent at a time before expecting the acknowledgement from the receiver. It uses the principle of protocol pipelining in which the multiple frames can be sent before receiving the acknowledgement of the first frame. If we have first 5 frames and then the concept is go back 3, which means that the 3 frames can be sent. Frame number 1, frame number 2, frame number 3 can be sent before expecting the acknowledgement of frame number 1. In go back NRQ, the frames are numbered sequentially as go back NRQ sends the multiple frames at a time that require a numbering approach to distinguish the frame from another frame, and these numbers are known as sequential numbers. The number of frames that can be sent at a time totally depends on the size of the sender's window. So we can say that n is the number of frames that can be sent at a time before receiving the acknowledgement from the receiver. If the acknowledgement of a frame is not received within a agreed upon time period, then all the frames available in the current window will be retransmitted. Suppose we have sent the frame number 5, but we didn't receive the acknowledgement. So the current window is holding the 3 frames. So the current window is holding the 3 frames. Suppose we have sent the frame number 5, we didn't receive the acknowledgement of frame number 5, and the current window is holding 3 frames, and then the 3 frames will be retransmitted. The sequence number of outbound frames depend upon the size of the sender's window. Suppose the sender's window size is 2, we have 10 frames to send, then the sequence numbers will be 1, 2, 3, 4, 5, 7, 10. Let's understand through an example. N is the sender's window size. If the size of the sender's window is 4, then the sequence of the number will be 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, and so on. The number of bits in the sequence number is 2. To generate binary number sequence 0, 0, 0, 1, 1, 0, 1, 1. Working of go back NRQ. Suppose there is a sender and a receiver, and let's assume that there are 11 frames to be sent. These frames are represented as 0, 1, 2, 3, and so on to 10. And these are the sequence numbers of the frames. Mainly the sequence numbers is decided by sender's window size. But for better understanding, we took running here we have discussed that n is the window size. The size of the sender's window is 4, then the sequence number will be 0, 1, 2, 3, 0, 1, 2, 3, and so on. So let us discuss the working of go back NRQ. First, the sender will send the first 4 frames and receive the 0, 1, 2, 3. And now the sender is expected to receive the acknowledgement of the 0th frame. Working of go back NRQ. See here we have sent the 0, 1, 2, 3 frames to the receiver where window size is 4. Let's assume that the receiver has sent the acknowledgement for the 0th frame has successful and the receiver successfully received it. Here we have see clearly in this image. The sender will then send the next frame 4 and the window slot containing 4 frames 1, 2, 3, 4. No 4, 4. The receiver will then send the acknowledgement for the frame number 1. After receiving the acknowledgement of the sender will send the next frame, frame number 5, and the window will slide having 4 frames 2, 3, 4, 5. Likewise. Now let's assume that the receiver is not acknowledging the frame number 2. either the frame is lost or the acknowledgement is lost. Instead of sending the frame number 6, the sender go back NRQ, which is the first frame of the current window, retransmits all the frames from the current window 2, 3, 4, 5. See here, we have again retransmitted our frames from 2, 3, 4, 5. Here we have didn't receive the acknowledgement of the 2. So we have sending again from the starting 2, 3, 4, 5. Important points related to go back NRQ. In go back NRQ, N determines the sender's window size and sender receiver windows is always 1. It does not consider the corrupted frames and simply discards them. It does not accept the frames which are out of order and discards them. If the sender does not receive the acknowledgement, it leads to the retransmission of all current window frames. Example 1. Let us discuss with an example. In GB4, if every sixth packet being transmitted is lost and we have to send 10 packets, then how many transmissions are required? Here GB4 means that n is equal to 4. The size of the sender window size is 4. As the window size is 4, so 4 packets are transferred at a time. Packet number 1, packet number 2, packet number 3, and packet number 4. Once the transfer of window size is completed, the sender receives the acknowledgement of the first frame, packet number 1. As the acknowledgement receives, the sender sends the next packet, packet number 5. In this case, the window slides having 4 packets, 2, 3, 4, 5, and excluded the packet 1 as the acknowledgement of the packet 1 has been successfully received. Now the sender receives the acknowledgement of packet 2 after receiving the acknowledgement of packet 2. The sender sends the next packet, packet of number 6, as mentioned in the question, that every sixth being lost, but the sender does not know that the sixth packet has been lost. The sender receives the acknowledgement for the packet number 3 after receiving the acknowledgement of third packet. The sender sends the next packet. The window will slide having 4 packets, 4, 3, 5, 7. The sender receives the acknowledgement for the packet number 3 after receiving the acknowledgement of third packet. The sender sends the next packet, 7th packet. The window will slide having 4 packets, 4, 5, 6, 7. When the packet 7 has been sent, then the sender receives the acknowledgement of the packet number 4. When the sender has received the acknowledgement, the sender sends the next packet, 8th packet. The window will slide again 4 packets, 5, 6, 7, 8. So when the packet 8 is sent, then the sender receives the acknowledgement of packet 5. On receiving the acknowledgement of packet 5, the sender sends the next packet, 9th packet. Window will slide having 4 packets, 6, 7, 8, 9. The current window is holding 4 packets, 6, 7, 8, 9. The 6th packet is first packet in the windows. As we know, the 6th packet has been lost, so the sender receives the negative acknowledgement. As we know that every 6th packet is being lost, so the counter will be restarted from 1. So the counter values 1, 2, 3 are given to the 7th packet and 8th packet and 9th packet respectively. As it is go back, so it retransmits all the packets of the current window. It will resend 6, 7, 8, 9. The counter values of 6, 7, 8, 9 are 4, 5, 6, 1 respectively. In this case, the 8th packet is lost at it has a 6 counter value, so the counter variable will again be restarted from 1. See here we have seen this. After the retransmission, the sender receives the acknowledgement of packet 6. On receiving the acknowledgement of packet 6, the sender sends the 10th packet. Now the current window is holding the 4 packets, 7, 8, 9, 10. When the 10th packet is sent, the sender receives the acknowledgement of packet 7. Now the current window is holding 3 packets, 8, 9, and 10. The counter values of 8, 9, 10 are 6, 1, 2. As the 8th packet has 6th counter value, which means the 8th packet has been lost and the sender receives the NAK of 8. No acknowledgement of 8. Since the sender has received the negative acknowledgement from the 8th packet, it resends all the packets of the current window, which is 8, 9, 10. So this is the example. So the counter values of 8, 9, 10 are 3, 4, 5 respectively. So the acknowledgement has been successfully received. Thanking me for giving me this opportunity.